Guys, welcome to my YouTube channel. In this video, I'm going to teach you about surface chemistry. In my previous video, I have been talked about surface chemistry. This is its part 2. Part 2. If you didn't watch my first video, please go and watch my first video. Then only you can able to understand the second video because it is a continuation of the first video. Okay guys, let's go into our chapter. Before entering into my chapter, please subscribe my channel. If you didn't subscribe it, and like my channel if you like it, or dislike my channel if you don't like it, and comment me what is the problem in my channel, and it will be very helpful for me to rectify my mistake and improve my channel. Okay guys, let's go into our video, surface chemistry. Okay, in our previous video, just we will see a small recap about our previous video. We will see in absorption, absorbent and absorbate in absorption, and different types of absorption, physical absorption, chemical absorption, and what is in the absorption also we had been seen. Everything we had a difference between them and factors influencing absorption. These are the types. Okay guys, just we will move ahead. Now we're going to see about absorption of solution from solutes. In this video, I'm going to teach you about the absorption of solutes from the solution. In our previous video, we had been seen that the absorption of gases in solution, absorption of gases in solution, solvent things. Gas is absorbed in a solvent. We have been seen in about that in our previous video, and what are the factors influencing that. Now in this chapter we are going to see about the solutes from the solution, absorption of solutes from the solution. You will know about the solutes, what is meant by solute and solvents. Solvent, for example, salt is a solute and water is a solvent. When we dissolve it, it forms into a solution, salt water. Okay guys, let's move on it. I have been given few pictures below it. This I will explain about the pictures in the further coming sessions. We will move about there are absorption of the solute from solution. It's of two ways. Absorption of solute from the solution is of two ways. Adsorbents absorbs dissolved substances from the solution. Adsorbent absorbs dissolved substances from the solution. I will give you the example and the completed explanation about that. First, just you want to know about the types. Okay guys, next thing, an absorbent also absorbs certain substances from the solution in preference to other substances. Okay, there are two types of absorption, means physical absorption, chemical positive positive absorption and negative absorption. First, okay guys, first I will talk about first thing, absorption. Absorbents absorbs dissolved substances from the solution. What does mean by that? I will explain you. Just see this thing. Wait a while guys. See this thing. It's a solution. Oh, okay, just see this guys. It's a solution. You can able to see this, I think so. Clear. It's a solution. It's a solution of like sugar solution. You can consider it as a sugar solution. It has some yellowish color. A sugar solution has some yellowish color. It is called as a coloring matter. Coloring matter means the substance which gives a color to the solution is called coloring matter. Let's consider this as a sugar solution. Okay, next one is an activated charcoal. When we pour some of the charcoal in the third beaker, you can able to see when we pour some of the charcoals in the sugar solution, and the charcoal absorbs all the solutes, which the sugar is a solute. It absorbs all the solute and leave the solvent, means the water. We will get a pure water without the addition of sugar. So this is a positive. This is the first example. What first point we had been seen here: absorption of absorbent dissolved substances from the solution. Absorbs dissolved substances means the solutes. which they dissolved. For example, that means an absorption of a colliding material present in sugar solution. This one is an example for that. And another example also I can give it for you, just you can note it. It's also absorbs certain substances like acids like CH3COOH, and COOH twice present in water. Thereby the acid concentration in the water decreases. It also absorbs NH3 from the solution of NH4OH and phenolphthalein. Okay guys, next we will move to the second point. The adsorbent also absorbs certain substances from the solution in preference to other substances they had been given. For example, that I will given charcoal. Same thing, the charcoal which is here, it absorbs non-electrolytes more readily than electrolytes from the solution. In alumina, another example is alumina. Alumina, it absorbs electrolytes more readily than non-electrolytes from the solution. Charcoal and alumina are opposite. Charcoal absorbs non-electrolytes more readily than electrolytes, and alumina absorbs electrolytes more readily than non-electrolytes. Okay, next we will move to next thing, factors influencing adsorption of solutes from solution. Okay guys, okay, just we will move to factors influencing adsorption of solute from solutions. Factors influencing adsorption of solutes from solution. Okay guys, I think can you able to see this now? Okay, factors influencing adsorption of solutes from solution. They are divided into three types. Effects of temperature and concentration. Temperature and concentration is very important in surface chemistry. In our previous video also we had been talked about temperature and concentration. Surface area, in our previous thing also, in gas absorbed in solid also we had been studied about talked about temperature and concentration. Surface area, nature of the solute absorbent. Had been talked these three, but we had been talked more things in that, like thickness of the absorbent and activation and also reversible characters, effects of pressure and gases, also temperatures, enthalpy, heat, nature of the surface area, nature of the gases, and also activated absorbent effects. Like that we had been talked about many things. Here also we will talk about temperature and pressure, and we talk about that separately. Okay guys, just we will see about this. First of all, effects of temperature and concentration. First thing we are going to see is effect of temperature and concentration. Extent of adsorption of a substance from a solution depends on the temperature and concentration of the solution. This means the amount of the substance absorbed by the absorbent depends upon the temperature, the room temperature or any different specific temperature we are keeping that, and also the concentration of the solution. In this they are given into two types. It means the first point we are given into two types. It's a physical positive adsorption and negative adsorption. Okay guys, positive adsorption means when the solute is absorbed by the absorbent is called positive adsorption. If the solvent is taken up by the absorbent is called negative adsorption. First we want to see about the positive and negative adsorption. You can able to see here, I think so, in this picture the solvent is not absorbed by the charcoal. Only the solute, means the smallest amount of the substance which we added in the solvent to form a solution, it's known as solute. The charcoal absorbed the solute and leave the solvent. It's an example of positive adsorption. Negative adsorption, molecule particle is favor of bulk, increase in the surface tension. Molecular positive adsorption, you can able to decrease in the surface tension. In this you can able to see, if the charcoal absorbs the water and leaves the sugar in that place, means it will not happen. Just for an example, I'm saying that if it leaves the sugar and it absorbs the water, means it is a negative example of negative absorption. It will not happen. Just I'm saying for an example. Just you can consider it will be easy if you think like opposite for charcoal itself, means it will be easy for you to remember. I am remembering like that only, so only I am saying that thing to you. Okay, next thing we will go to next thing, and something we want to know about positive and negative absorption. Clearly, negative absorption of substances from the solute decreases with the rise in temperature. Negative absorption of the substances from the solution, absorption of the substances means the solutes. Substances mean solute. Solute decreases with rise in temperature. It decreases with the rise in temperature. Okay, guys, it decreases with rise in temperature and decreases in concentration of the solution, and decreases in concentration of the solution. Okay, guys. Next thing means it's in this types of absorption is known as negative absorption, and for positive absorption, absorption of substances from the solution increases with decrease in temperature and increase in concentration of the solution. This type of absorption is known as a positive absorption. This is the definition for that. Just make a note of it. It will be helpful for you. Okay. Next, we will go on to effects of surface area. This will move to effects of surface area. For this, for the first thing, effects of temperature and concentration, log x by m. X mass of the absorbate, amount of substance absorbate, whole absorbate, mass of absorbent, m is a mass of absorbent. If you see my previous video, I had been said you clearly what is meant by absorbent and absorbate definitions and all. Okay, next thing, water, log C, water. It's and for negative absorption, it's the line is coming from up to down. You can able to see there. It's an example for water from the dilute solution KCl. Charcoal absorbs water, thereby the salt concentration decreases. You can able to see it. Charcoal absorbs water, thereby the salt concentration increases. If it absorbs water, means the concentration will increases. We are diluting for example, you can see in your lab also, school labs also, they are diluting the acids with water. If we absorb water, what will happen? The concentration will increase. You can see the second graph, a positive absorption. It's the same thing. Salt, Cl, is from the concentrated solution of KCl. Charcoal absorbs KCl rather than water. Thereby salt concentration decreases. You can see the graph increasing. It means the salt concentration gets decreased by the KCl because it absorbing the substance which will cause acidity, increase in concentration for the solution. It absorbs the salt and leaves the water remain. For this is the example for that charcoal. Okay, next we will move to effects of surface area. Okay, guys, effects of surface area. You can able to understand clearly. If the surface area of the absorbent increases, the absorption also increases. If the surface area, you can just get in your mind, the absorbent increases, the absorption increases. If you increase the amount of charcoal in the third beaker, means the absorption will be increased rapidly. It will happen with the time will be decreased to absorb the solutes. Okay, if you add some only little amount of charcoal, means it will take more times and the absorption will be less. So it depends upon the surface area. The nature of the solution. Next, the third thing we will see, nature of the solute absorbent. Nature of the solute absorbent means the extension of the absorbent is usually greater when the molecular weight of the solution increases. Solution is high. The molecular weight of the solution is high means the absorption is high. I will explain it why means the third step in further. They had given a great good example and good explanation for that in our further slides. Just we will move towards that. Okay, now you had been cleared about I think you are been clear about adsorption of solutions from solute from solutions solutes from solution. Now we are going to see about adsorption isotherms. In this only I had been said the pressure and temperature takes place here. Temperature is in constant. First of all, the pressure, we are drawing a graph between pressure graph I will say it just drawing a graph between the adsorption isotherm is a relationship or a graph between magnitude of the adsorption with pressure at constant temperature. Here you can see they kept the temperature at constant, but they are changing the pressure. And normally you can, for example, I will give a simple example to you. A simple, very simple example. If you are poured some water in your surface and you are using sponge, it will be a best example, sponge, because we are using sponge in our day-to-day life itself for spilling. If we spill something, we will use the sponge. Or an example of a chalk piece also. If you spill some ink or something in your note, means we will use chalk piece to absorb it. It will absorb easily. For now I will let's take sponge. If the water spill, means if you just keep the sponge above the water, means the absorption will be very slow. If you press it, means the absorption will occur very high due to pressure in it. Okay, now we'll go to the definitions. You can able to see the graph. From the graph, it is clear that the extent of adsorption x by m increases with increase in pressure, and because at a maximum at ps, you can see the line ps, a maximum at ps, it's a saturation pressure. At ps, the rate of the adsorption becomes equal to the rate of the disabsorption, thereby dynamic equilibrium is reached. You can see at the constant saturation pressure, the dynamic equilibrium is reached. After this, if you give more pressure, means it will disabsorb. Disabsorption will occur. Further increasing the pressure does not alter the equilibrium. Okay, guys. Just next thing, types of adsorption isotherm. There are different types of adsorption isotherm. You can able to see here the different types of adsorption isotherm. A large number of adsorption isotherms of gas on a various of adsorbents at different temperatures has been studied. A large number of adsorption isotherms of gases on a variety of adsorption at different temperatures has been studied. The results are given into 5 different types of adsorption isotherms. Just you didn't consider the first one, linear. And this video I'm not going to say about that, because we are going to see about only 5 things. There are many terms, but we had been studied about 5 things. So we will see about the 5 things. Let's see about 5 things: L laminar and F, H, S, and step isotherm. Second picture means L. Laminas you can able to see. As postulated by Laminas, it corresponds to the monomolecular adsorption. The volume of the gas adsorbed approaches a limit value Ps, which is just enough to complete a monomolecular level, even when the gas pressure is low. Further increasing the pressure will not increase the amount of the adsorption. After a certain pressure, the absorption will be reach the equilibrium. You can see in this first video, first picture, they have been given more colorfully and clearly. reached it will not absorb it, because it reached the saturation point, so it will not absorb more thing, it will disobsorb. Okay, in another next picture means almost the second diagram. Both first L is the same diagram here. F is also somewhat same, because it just increases somewhat, and also it reaches the saturation point at a level. After that it will not go again, it will reach the saturation point. After that the disorption will occur. Okay, next we will move to S. We will move to S and step isotherm. S and step isotherm. In this you can able to see the isotherm indicates the possibility of condensation of gases in the minute capillary pores of the adsorbent at a pressure even below the saturation pressure. PS. This is not only due to the formation of multimolecular adsorption layer of the gas molecules, but also due to the condensation of some of the gas molecules within the capillary pores of the absorbent. This is known as capillary condensation. I think you know about the condensation means the vapor changes into water directly. It will not change into vapor will change into condensation means vapor will just a minute, guys. Vapor will changes into water. Okay guys, condensation means the vapor will change into water. Okay guys, this is happening in this diagrams, graphs they had been shown. And another type of gas, another type of graph what we are going to see means that graph they didn't mention here, I think so. Yeah, they didn't mention that kind of graph here. Just I will explain you. Wait again. In this graph you can able to see that the isotherm shows the large diversity of the Laminar's model. The amount of adsorption in each type is going to increase with increase in pressure. The y-axis is given as increase in the y-axis is for amount of adsorbed, and the x-axis is for pressure. It increases with increase in pressure. You can able to see that this is due to the formation of additional layers over the mono layer by van der Waals force of attraction. It has been suggested that the gas molecule adsorbed in the first layer may hold the second layer and of gas molecules by weak van der Waals force physical bonding, which in turn may hold a third layer, and so on. So it will increase with increase in pressure. We had been seen different types of graphs. These are all because of different types of gases are there, and different types of adsorbent layers are there in our day-to-day life. So they are been changing with different changes in temperature and absorbent. In this video we had been seen about only 5 graphs. I have been explained it to them, explained it to you guys. Next, in my next video I will tell about we will see about Freund-Liger's adsorption isotherm, and also about Lagminar's isotherms, adsorption isotherms. In my videos I had been saying about Lagminas and Lagminas. If you want to know about exact meaning for that, what is meant by Lagminas, just watch my another video, the upcoming video. You will able to understand very clearly what is meant by that. Okay guys, thank you so much for watching my channel. Please like, share and subscribe my channel to get my day-to-day updates guys. Okay, thank you.